All right, so to begin with, I'd like to show you something. So I have this triangle. I did make sure to make it a right triangle, as you can tell there. Um, so this is a right triangle, kind of like what we were dealing with for Pythagorean concepts. But this time we're interested in the angles. And I want to show you a little something. I'm going to tear off the corners or the angles. And just, it's going to be kind of a jig puzzle kind of thing. There's the second angle and the third angle. So basically this is angleless. And take a look at what happens. Again, this is kind of a jig puzzle type thing. And hopefully it all fits. And it does. So all three angles together make a straight line, right? So how many total degrees would you say that is? 180. Whenever two or more angles form 180, well, you get what's called a linear relationship there. They all form, 180 degrees. So was this a phenomenon of a right triangle, maybe? Possibly. Let me try this triangle. This is more of an obtuse triangle. So this angle is obtuse, but I'm going to do the same thing. And the obtuse angle. So let's see here. I'll put this here. Maybe, because sometimes they accuse me of putting the bigger angle in the middle, and that somehow does something. It doesn't, but there's this. And here's my final angle. And that's how many degrees total? 180. So that's going to be our first theorem that we're going to talk about. It's called the Triangle Sum Theorem, and it's real simple. The sum of the angles inside a triangle is 180 degrees. Okay? So let's go ahead and write that down. So get your pencil or pens ready, and this is going to be called angles of triangles. Jaime, focus on this. So this is, we're going to call this angles of triangles. Okay, and here we go. So, triangle sum theorem. The sum of the angles of a triangle is 180 degrees. All right. So let's just start answering some questions with this. Here's our first question. A right triangle has an angle with a measure of 40 degrees, comma, what is the measure of the other acute angle? So most of these questions are going to be along this line where they want us to find the measurement of some unknown angle. So they tell us that it's a right angle, right? Well, they tell us it's a right triangle, and then we have one that's also 40 degrees. And then we want to find, well, the other acute angle. So the right angle has a measure of what? 90 degrees. And we have one that's 40. And our third angle has to be acute, but it's just x degrees. And all of that has to add up to 180. Okay. Yeah. So we could simplify it. And this is what? 130 plus x equals 180. So what does x have to be? Yeah. There you go. Any questions? That's pretty easy, right? Okay, number 2. This one's a little trickier. We all have to remember what an isosceles triangle is. And isosceles, and I have to remember how to spell isosceles because I always put the C in the wrong place. An isosceles triangle, I'll just shorten triangle to that, has an angle of 40 degrees. Comma, what are the possible measures of the angles? So we have to remember what an isosceles triangle looks like. It's an angle with 2 equal sides. Not all 3 equal, just 2. Okay? 2 congruent sides. So why don't we draw one? This is what an isosceles triangle looks like. So which one could be possibly 40 degrees? Okay, it's possible that the bottom one is. Well, it's possible that the bottom one is. But here's the catch. Here's something unique to an isosceles. If it's the bottom one, we call it a base angle. Guess what this one has to be? 40 as well because of those equal signs. And this is the one we can call x. In which case we would get 80. Well, yeah, 40 plus 40. I don't want to lose anyone, so. We would get this, right? And this is 80 plus x equals 180. So x would have to be 100. Didn't really draw this accurately. These are obviously more than 40, but so it's possible that one of the angles is 100 if the base angles are 40, both 40. However, what if the 40 was this one, the top one? So let's draw that possibility. So this is one possible answer. And the other one is if we have something like this. Let's say these are 40, or this one's 40. And we know that these are equal, right? Because they have to be isosceles. Well, what do we know about these two angles? Yeah. And don't they also have to be the same? They have to be the same. They have to be what we call congruent. So let's just call both of them x. So the other possibility is that this vertex angle, we call it, is 40. So this is x and this is x. So we got x plus 40 equals 180. So this would be 2x. Is that what we get? Yeah, but usually you don't want to just say you're smart. We just know you are. Okay, so the other possibility is that this is 100 or you get 70. Now we could have lucked out. Say they gave us one that was acute. Say they gave us an angle that was like 100. If they would have said this is, instead of 40, if they would have said 100, then the only case we could have done is this one. We would have had to do this because you can't have two angles that are more than 90, right? Because if both angles are more than 90, it's not a triangle anymore. Okay? So if you see problems where they say something over than 90 for this isosceles type question, it only is this case here, not this one. Or, yeah, it would be this one. This would be 100, and then you would have to figure out what x is this way. All right. And then you may see a question like this. I'm going to draw a triangle. And they give you expressions for all the sides. So let's say this is 2x plus 4. Oh, I'm sorry. X plus 7. And 2x plus 9. Okay. So they're not giving us any angle, any real measurements. But what can we say about the sum of all three of those angles? They make up 180. So we could still set up this relationship. 2x plus 9 plus 2x plus 4 plus x plus 7 is 180. You can still say that, and that's 5x plus 20. So we'll get 5x plus 20 equals 180. Okay, so that would be 5x. And what does x have to be if we divide by? And there you go. And then if we needed to find each angle measurement, well, this would be 32 plus 7. And then 64, because it's 2x plus 9. 64 plus 4. You could get the angle measurements if you need them. I think they only ask you to find x in these type of questions. Okay. All right. So that's the triangle sum theorem. Okay. Just everything adds up to 180. Let's go ahead and look at the second theorem. You ready? Okay. I'm going to cover this up. And I'm going to show you another triangle here. So let's label these triangles. These triangles that are on the inside, guess what we call them in geometry? Interior angles. Makes sense, right? Do you see how this forms an angle on the outside? If this line is extended, guess what we call this angle? Exterior angle. So now we're going to learn the relationship between the exterior angle and the interior angles. So just remember, this is an exterior angle. And I'm going to do that little cut up method. Now, when something is remote, so if I say, wow, getting to Death Valley, it's really remote, far, and isolated. So we call this the adjacent angle. Adjacent means right next to it. So the exterior angle and the adjacent angle. Now, to the exterior angle, these are remote interior angles. So this is remote and remote. So we have adjacent angle to the exterior. It's close to it. It's right next to it, in fact. So I could say Miss Coronel is adjacent to me. We share the wall. This shares one side. These two angles are remote. They're remote interior angles to the exterior. They're not close. And look what I'm going to do. I'm going to tear these up again. So I'm going to tear up those remote angles. Okay? And I want to line this up, line it up, lined up. Okay. And look what's going to happen. I'm going to drop my Sharpie. So I'm going to take my angles and do this little jigsaw puzzle thing again. And lo and behold, this is a consequence of the theorem we just saw. But these two have to form 180, right? But do you see that the exterior angle equals the two remote interior angles? These two angles add up to that big angle. Okay? That's the exterior angle theorem. The sum of the remote interior angles equals the exterior angle. And we're going to use that, okay? So first, let's write down that theorem. So, new theorem, and I think we'll just do one more problem and then we'll be done. Okay. All right. So this is the exterior angle theorem. Oh no, we have to do two. All right. So here we go. Okay. So here's the theorem. The sum of the exterior angle is equal to its remote interior angle. Okay. So what that means, I'm sorry, we have to do two problems with it. They'll be, the first one's super easy. What that means is, so if I give you a triangle, something like this, and we extend one of the lines, and I tell you this is 54, and this is 79, and the exterior angle is x, how can I figure out what x is? Yeah. Add the remote interior angles. So x is going to equal 54 plus 79. All right. And so x is going to equal 133. Check my math. All right. So what they like to do on the SBAC is give you something not easy like this, but it won't be very hard, I think, for you guys. Number 2, and then this will be the last one. They'll give you something like this. And they do this because they can test you on 2 skills. Your skill to solve linear equations and your knowledge on this. Okay, so we have x plus 44, 13x, and then 25x minus 22. But you use the same idea. This equals these two put together. 25x minus 22 equals this plus that. So set up an equation. The exterior angle, 25x minus 22, equals plus x plus 44. Okay, and we'll just solve it. Well, we know that we have to combine like terms on the left, so let's do that. 25 x minus 22, 14x plus 44. Yeah, let's get rid of, we got variables on both sides, so let's take care of that. And again, I like to get rid of anything on the right that has a variable. Okay, so what's that going to be? So that works out nicely because now that's going to be 11x equals 66. So x has to equal 6. Okay. And so that's about as hard as they get on this stuff. Any questions? So you'll have questions on triangle sum where they add up to 180, and then you have questions on exterior angles where the outside angle equals the sum of the inside angles, or two remote interior inside angles. Okay?